Okay, so in this video we're going to talk about choices or combinations or choosing. In a previous video we looked at arrangements or permutations, and what we did was we looked at, say, arranging letters in words. So for example, if you use the letters A, B, C, and then you had C, B, A, they're two different arrangements or two different permutations. However, when we're talking about combinations or choosing, these would be the same. We would only count these as one choice because they have the same letter. So that's what we're going to do in this video. Just look at combinations or choices. Um, so let's have a look at some of the basics first. So we're going to look at what you would do on your calculator. On your calculator, you should have a button that looks something like this, and C for choices. Um, so this would be choosing or from n number of things. You're choosing or number of things from n number of things. So another way of writing that would be n or. It may look like that on your calculator. You can use either, it doesn't really matter. Now the formula that we normally use here is n factorial over or factorial times n minus or factorial. So these are in your maths tables as well, so you don't really have to remember it. But you can use this button on your calculator. It'll look like this, or you can use the formulaic way of doing these questions. Just a couple of things that you need to remember before we start as well. That n0 is equal to 1. And that's also exactly the same as n. So if these two numbers are the same here, your n and r are the same, you'll get 1, and n choose 0 will also be 1. The other thing you got to remember is what's called the twin rule. So the twin rule means that if you have n choose or, that's exactly the same as n choose n minus or. So for example, if you've got let's say 7 choose 3, that's exactly the same as 7 choose 4. So you just subtract 3 from 7 and you get 4. So you subtract that number from this number, and that'll give you this number down here. These two, you get the same result if you do these two here. So that's called a twin rule. And it'll make some of these calculations, if you have to use the formula, make some of these calculations easier if you keep this twin rule in mind. So let's just have a look at what this actually means in practice. 7 choose 3. So really what you can imagine here is that if you have 7 people, for example, lined up in front of you, and you have to choose a team of 3 people to play some sport, for example. So you have 7 people lined up in front of you and you have to choose 3 of them. You do 7 choose 3 on your calculator. That's one way of doing it. So just type 7 choose 3 into your calculator, press equals, and that'll work for you. Or if you use the formula, effectively what happens is you take 7, multiply it by 6, multiply it by 5. So you go down 3 places. So you start at 7, 6, and then go down to 5. Divide by 3 factorial, 3 times 2 times 1. This is effectively what you're doing from this formula here. So you've got 7 here, 3 here, so you take the 7, you go down 3 places, or another 2 places if you like, 3 in total, and then on the bottom here you do 3 factorial, 3 times 2 times 1. If you take 7, choose 4, you should get the same answer as well. So here you would go 7 times 6 times 5 times 4. over 4 times 3 times 2 times 1. So that you should get the same answer there. This here is actually 7, choose 4. Go down 4 places here because you've got a 4 here. So this is the formulaic way of doing it, or you can use your calculator either. Okay, so let's look at examples of how that actually works. So I'm going to take, let's see, I'll just change this to white. So we're going to look at an example then, okay? So what I'm going to do is, the question will be, how many ways can a committee of 4 people, so we're going to try and choose 4 people from a total of 10 people. Okay, so we've got 10 people lined up in front of us, and we want to choose 4 people. Now, you can do that in any way that I've shown you up here, but let's just see. We'll take we'll use our calculator here. Well, we do it both ways actually. So what you do is just write down 10, choose 4. So we want to choose 4 people, and we want to form a team or a committee of 4 people, and we've 10 people to choose from. So it's just 10, choose 4. So in this case, then you stick that into your calculator, and you should get 210. Or if you want to use the formula to do it, you can do it the long way here, or effectively the formula means that you're going to do 10 times 9 times 8 times 7. You go down 4 places because we've got a 4 here, and then it's 4 factorial on the bottom, which is 4 times 3 times 2 times 1. You should also get 210. Okay, so that's choosing a committee of 4 people from a panel of 10 people. So let's just put a restriction in there. Let's say that from this panel of 10 people, there's one particular person that we have to choose. One person has to be on the committee. So what does that mean? From these 10 people that we have lined up in front of us, we have to choose one person. So we take that person, and we are left with 9 people. So from the 9 people then, so in other words, really what we've got is our n here in the second part of this example. Our n is going to be 9 because we've taken one person, so we've got 9 people left. And our or, how many people do we have to choose from those 9 people? Well, we only need a panel of 4. We already have one person, so our or is going to be 3. So really what we have to do is 9, choose 3. And again, that's the same as, you can do it on your calculator, same as up here. You can do 9 times 8 times 7, because we go down 3 places because there's a 3 here, over 3 times 2 times 1. So that will work out at 84. So use your calculator or just work this out, you'll get 84. So there are 84 ways of choosing 3 people from 9, or choosing a panel of 4, choosing a team of 4 or a committee of 4 from 10 people if one person must be on the committee or on the team. Okay, so let's just put in another restriction. Let's take let's say that one person must not be on the committee. There's one person in that group of 10 who should not be on the committee. So in other words, you have to take one person out of that 10 and just move him to the side, so you're left with 9 people standing in front of you. So n is 9. Now how many people do you have to choose from this 9? You still have to choose your the 4 people. So or is going to be 4. So you got to choose 4 people from 9. So this is just 9, choose 4. That's going to be 9 times 8 times 7 times 6 all over 4 factorial, which is 4 times 3 times 2 times 1. If you do that, you should get 126. So there are 126 ways of choosing 4 people from 9, or there are 126 ways of choosing 4 people from the 10 if one person must not be on the committee. Okay, so that's one example. I'm going to do another example now, Example number 2. Okay, so this example is this one is going to involve some maths books and physics books. Okay, so basically what we've got here is we have, let's say in front of us we've got 8 maths books. Okay, and we also have 6 physics books. Sorry, that's a Y there. So we have 6 physics books and we have 8 maths books. Now the question is, how many bundles of 5 different books? So we want to choose from these two, and we want 5 books. But we have a condition here that there must be more maths books than physics books. So how many bundles of 5 different books can be made from 8 maths books and 6 physics books if the number of maths books must always be greater than the number of physics books? So we have to have a bundle of 5, but within that bundle of 5 we must have more maths books than physics books. Okay, so really the way you would tackle this is to first of all just write it all out in English, and then really just translate the English to maths, and then just work it out. So let's have a look. What are our possibilities? Remember, we have 5 books and we always must have more maths books than physics books. So let's have a look at that. What are the possibilities? Well, we could have 5 maths books, and we could have no physics books. No physics books. That's one possibility. Another possibility, or we could have 4 maths books and 1 physics book. Or we could have 3 maths books and 2 physics books. Now if we go further, we would have 2 maths books and 3 physics books, but remember that would mean we would have more physics books than maths books, which we don't want. We must have more maths books than physics books. So these are the only possibilities: 5 and 0, 4 and 1, 3 and 2. Always have, in these 3 possibilities, we always have more maths books than physics books. There are no other possibilities. Now, the important words here are and, or, and, or, and. Now I'm going to translate this English sentence here, if you like, into maths. So let's have a look at doing that. I'm going to take this part here first. 5 maths books. We want to choose 5 maths books from a total of 8 maths books. So that means we have to write 8, choose 5 here. So that's choosing 5 maths books from 8 maths books. Now, and in this case will always be multiply. We're going to times or multiply here. Now we've got 0 physics books, so we have to choose 0 physics books from 6. So it's 6, choose 0. Okay, so the next word that we come across is or. Whenever you see or in probability, it's always adding. So we're going to put a plus here. Then we're going to choose 4 maths books from 8. So that's 8, choose 4. Again, we've got an and here. So the and is times. Then we're going to choose 1 physics book from 6 physics books. So that's 6, choose 1. We've got an or here again, so that means we're going to add. Then we've got 3 maths books. We have to choose 3 maths books from 8 maths books, so that's 8, choose 3. We've got an and here again, so that means we're going to multiply. And finally we have 2 physics books to choose from 6, so that's going to be 6, choose 2, and that's it. So this is our English sentence here, this is our math sentence here, if you like. Okay, so we've got to do each one of these individually on our calculators. We're choosing 8. We're choosing 8 here from, we're choosing 5 from 8, so that should give us 56. We're multiplying that from 6, choose 0, remember from up above that's just 1. We're going to add, choosing 4 from 8, that's 70. We're going to multiply that by 6, choose 1, which is just 6. We're going to add again, and 8, choose 3, that's 56. And then we're going to multiply that by 6, choose 2, which is 15. So if you do those individually, you should get, let's see, 56 times 1 is 56. We're going to add 6 7s, 42, that's 420. And then we got 56 times 15, that's 840. And when we do that, then we have we have let's see, that's going to give us a total of 1316. 1316. So finally, there are 1316 different ways of choosing 5 books in total, where there are rather more maths books than physics books. And that's it. Okay, thank you.